Hello everyone, today let's solve the daily question 1277. Now I have seen a similar solution like to this problem before. It was one of Google's own solution on YouTube. I'll link that video down below if you're interested. So given a matrix which has m rows and n columns, return how many square submatrices are there. Okay, so how we would solve this is using recursion. So every time we find a 1, let's say this is our matrix. Geez. Okay. So 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay. So every time we find a 1, what we can do is we can call the same function on the adjacent ones. So that is right, bottom, and then diagonal. And then if and then that function would return the length of the maximum square that can be formed. So let's say we call the function on 1 comma 2, so that would call function on this and this, and each of these three elements can form a 2 by 2 matrix. Okay, and then we take the minimum of these and add 1. So if this is a 1, and after we call the function on these three elements, the minimum is 2. So 2 plus 1 is the max length of the matrix you can form. Does that make sense? Yeah. And if we can form a square, we don't need the length in this problem, but if we can form a square, all we have to do is, let's say we have an increment called result or count or whatever, and then we increment the count by 1, if we can form a square. And since we're calling the function recursively, uh, this one calls the function on this, so this 2 by 2 square is counted, and that calls the function on this, and this, and then that's how it works. So maybe if you can, I'll try coding it up. If it works, you can understand. Okay, so initially let's have the number of rows and columns. Let me just, okay. So number of rows is length of the matrix. Number of columns is length of the matrix. Okay. And now we need a visited array as well. So visited is empty initially. And let's say our function, this is basically a depth first search. I think so, right? Yeah, right. The row and the column. So if comma c in visited, then we return 0. Mm, and we only perform the DFS if the number is equal to a 1. So if it's 0, we'll return 0. Okay, and then what? So then we need so left is equal to DFS of, okay. So if r plus 1 in range the length of the rows, right? So let's say if r plus 1 lesser than or equal to the number of calls, right? So row comma column, the number of rows lesser than rows, then left is equal to left comma down comma diag is equal to 0. Okay, and now if column plus 1 this is first of all not left, it's right, and down, and right is equal to dfs of comma this 1. Now we need both the conditions for this. So if this and this, right, and then we return the minimum of, okay, now what do we return? So we return the minimum of these three, so that is right, down, and then diag plus 1. Does this make sense? We also have to add it to the visited, right? So for that, yeah. Wait, do we even need a visited set here? Maybe we. No, we do need it here. So I know this function will not access anything in the visited array, so we can just visited dot add c. Should be fine. Let's just try if our function is working. So let's print out. Let's look at this example here. So here it's 0, 1. So let's print dfs of 0, 1. See if it works. I'm sure there's some errors. The list object is not calling. Okay, this is a stupid mistake. Right. Okay, I did get the wrong answer for some reason. And along with Okay, let's see what's going on here. So 1, comma 2. Okay, so 1, comma 2. 1, comma 2 is a 2. Wait, okay, I get it. I think yeah, we do need to cache it because, but even if we don't cache it, it should work. Why is it giving me different answers for the same input? So 1, comma 2 is 2, 1, comma 2 is 1. But that's because we added it to visited. Oh, that's the mistake. So let's just say let's say this is a default dictionary, I guess. Let's import that, make it a practice from collections tick. And now, okay, so what we can do is if r comma c in visited, then we return visited of c. That should ideally work now. Right, and this is not add, this is just this now. One comma two. Oh, okay, this is fine. R plus 1. Okay, this is my bad. I'm printing it the wrong way. That's why I was getting confused. So 2 comma 3 is 1, which is right. So everything's returning 1, and that's the problem. And I also need to add it to the visited. So visited of R of C is equal to just is equal to that. Perfect. So now we know our function is working, right? So this function is returning 3, and which is absolutely right. So our DFS function is fine. Let's just clean this up. Yeah. Okay, now what we have to do is um so we can have a universal result, and whenever it's is there a universal formula to find the number of squares? Let's say uh 2 by 2 square is given. So it's 1 2 power. Okay, wait, let's say 2 by 2 and 3 by 3. We have 2. That's so it's 1 into 4 plus 2 into 1. And here it's 3 into 9 plus 2 into 4 plus 3 into 1. So let's say for a 4 by 4, it would be uh, one into check. Okay, so for a 3 by 3, for a 1 by 1, it would be 1. 2 by 2, it's 1 plus 4. 3 by 3, 1 plus 4 plus 9. Yep, 9. 4 by 4, 1 plus 4 plus 9 plus 16, I guess. 4 by 4. Okay. Sorry, my drawing is not that great, but okay, there are 16 thing, and then 1, 2, 3. Yep, that sounds right. Yeah. So if n is the length of the square, we need to find the sum of n squares. So this is equal to 1, this is equal to 5, 9 plus 4, 13, it's 1, 14, 16, 20, 21, 30. Now I remember there's something to find the sum of squares. 2 into 2n plus 1 by 6 or something. Is that right? Wait. So what does this give you? 2 into 2n plus 1 by 6. So 2. What's 4? 4 plus 5. 4 plus 1, 5. 5 into 2, 10. No, that doesn't work. How do I find the sum of squares of numbers? Wait. 1 square plus 2 square plus 3 square up to n square. You need the value of this. Now I don't know how to derive this. I'm just going to Google it for now. Sum of squares of numbers. N into n plus 1 to n plus 1 by 6. Okay, so n into n plus 1 to n plus 1 divided by 6. Wait, let's see the derivation as well. I'm quite curious. I remember studying this for my exams, but yeah. Okay, fine. This is for another video, but anyway. So the solution is n into n plus 1 into 2n plus 1 divided by 6, and that will give you the number of squares you can form if there's one big square. So, and now all we have to do is iterate through um, all the digits in the matrix. So for I and let's just call it R in range rows, for C in range columns, what we have to do is if okay, so the length max length is equal to the DFS of the DFS of R comma C, and if it's already in visited, we don't need to visit it again because that would count it twice. So if my bad. If R comma C not in visited, then we do that. Okay. And then max length result is equal to 0. So all we have to do is add this max length. So result plus, okay, number of squares. Square num is equal to n into n plus 1. So let's just call this n for convenience. So n into n plus 1 into 2 times, okay, like 2 doesn't work, so 2 times n plus 1 divided by 6. And then we add, let's just add this to the result direct. There we go. Yep, that should work. And then we just return the result. Let's see if this works. Okay. Okay, 1, 2, 3, 4, 5, 6, and 7. Okay, I get the problem. Okay, the problem is that well, this one calls this, uh, and then you get a 2 by 2, but we're not adding it again because it's already envisaged. So I'm just going to go with the simplest solution, and let's have a global variable result. And every time, so there's non-local, and every time we, yeah, if if this is not zero, basically, okay, if this is not zero, yeah, it's already done, right? So we just increment the result by one, and then we can just skip this part for now. And let's, okay, I can perform the DFS here. Still mistake now, expected 10. Still missing something. Let me think. I think I can see why this is wrong as well. Wait, let's analyze this test case. So this calls, so we get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but yeah, that that is wrong. That's just wrong. Because we can form more than 9 squares. Okay, what I'm gonna do is stick to our original plan. And what we can do is we can have a separate yeah, we can have a separate visited. So visited 2 is equal to, and this just has to be a set because we just don't want to visit it again. No, we don't even need a visited, right? We can just remove this. Okay, but the problem is, yeah, uh, we're counting this again. That's the problem. Wait a minute. Why does our initial solution not work again? It's for the second test case. Okay, that makes sense. Okay, I think it's simple. All we had to do was So now what we're doing is calling this, and only the first time we call it, then we're adding it. I think this should work. This N. Oh my god. Okay, 2 comma 3, right? What is this? 2 comma 3 and 1. 2 comma 2 comma 2. Because the order also matters. I wait, I think the diagonal has to come first, if I'm not wrong. Okay, let's see what's. Okay, I don't think matters for it. 2 comma 3. 1 2 comma 3. One comma 3. 1 comma. Okay, wait. Yeah, I got into the mistake here. They're adding everything again. Yeah, this shouldn't come here. So what can we do? The problem is with this thing is calling this. How about we store? Okay, wait. Yeah, the thing is, if the minimum is not zero, the minimum is not zero, We subtract the other ones. Wait, let's have define x squares and in case we don't, what we have to do is, okay, so rest plus equal to get square get squares of n minus get squares of minus one number we have to subtract. So minus one number. I think this is probably the right way to do it. Like 2, 3, 1, 2, 2, 2.
Listen, man.
Wait. Why am I adding res again? Okay. How about this? No, that won't work. Wait, if we have something like this, we can form 5 rectangles. Let's say we create a third one. So the answer would be 9 minus 5, which is what I have done. No, no, not 9 minus 5. It's 1, 2, 3, 4, 5, 6, 7, 8. 1 plus 4 plus 9, 13, 14 minus 4 is equal to 9. One, two, three, four, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that makes sense. Where am I counting the extra ones? What am I missing? Can I do something like this? If I this question, only if I find the they only mark the length as visited. Yep, I think that makes sense. Okay, that does make sense. But it is slightly inefficient, but I think that's how we're gonna do it. So visited two is equal to set. Let's get rid of this for now. Okay, and every time, let's say n is equal to that. Okay, and we need to add that to visited at the end. So for AC dr range R2 R plus N. So I have a square here. Some element is I comma j. Let's say two elements, one, two, three, four. So I can do this first. I need a loop regardless. squares. Right, and it should be working now. I don't know if this will get a time limit exceeded. It's not that bad, but wait, a small mistake here. One zero one zero one 101 01 1001 1010. Okay, this doesn't mark this. 1 2 3 4. Wait. This doesn't work. My logic is flawed. Yep, this is just wrong. This is blatantly wrong. Then that's also wrong. Okay, so let's assume we traverse through every element, find the largest length, or I think if we can only add the number of new n minus 1 squares, which is 2, plus 3, 4. Take the minimum. R is equal to 2. 1, 2, 3, 4. We have 1, 2. Wait, no, what is that? It's on a square. Wait, it is 9 minus. How do I calculate the number of new stuff? One, 2, 3, 4. 4 plus. But how many new things can we create with this particular node? That is the important part. So that is 1, 2, 3, 4. So that's just the length, right? Oh, it's that simple. So every time, okay, so every time okay, we don't need this. It's just adding n each time. I think that's what this is. Every time we get a new thing, we add 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It should work. Should work. Okay, res plus equal to n. Why did I do 1? Perfect. That's it. I think that's it. Let's try submitting it now. It should. Yeah, I'm confident. Yeah, let's go. So yeah, that was the solution, everyone. Thank you for watching. Have a nice day.